Chapter 1, Section 7, Multiplication and Division of Real Numbers. Well, we talked about addition, subtraction last section, which was really a lot of the strategies as far as problem-solving strategy is about converting subtractions into additions by using additive inverses and opposites and those kinds of things, and they gave us a lot of rules about adding when we have different signs and those kinds of things, which are good. You know, they talked about absolute values, and which is a distance from zero. But probably the best strategy for addition, and why I'm repeating this again, is that when we usually don't see any problems with the rules of addition when you have a negative plus a negative. They talk about that means you're going to have a negative sign on your sum, the answer to the addition, and you take the absolute values and take the sign of the two of them, and then if it's positive and positive. But they got a bunch of rules, and I don't see any students have problems with those rules until it comes to multiplication, and then he starts thinking things, well, when I see two negatives I'm supposed to have a positive result. Well, that's how it works with multiplication, but not with addition. So I just want to tie back to, with addition, a very good technique and a good way to make sure that you stay on the right track is to think of a number line addition. Draw it out. Think of that picture. I'd actually draw some number lines in parts of your homework. And, if you're adding -5 plus -7, you'd start at 0. I'd go left on your number line 5, and then left again 7 more, and you end up at -12. And if you just think about that, if I'm going to move to the left to 0 twice, go in the same direction, I'm definitely going to stay on the negative side of 0 or left side of 0. That visual can really help make sure you stay clear, especially when we start adding more material. Now, multiplication and division, they're going to set up some patterns here. They're showing us some patterns where if I had, think about what 4 or multiplication really is multiple addition. So 4 times -5 is -5 plus -5 plus -5 plus -5. So you'd move to the left 5, another left to the 5, never left to 5, and another left. And you're going to definitely end up at a negative number. You end up at -20. Well, 3 times -5 is -15. 2 times -5 is -10. 1 times anything is that same thing back. That's the identity property of multiplication. And this is a 0 property they're going to talk about some more too. But there's a pattern that's going on here, and they're going to show us a little later in the section what happens when I have negatives times negatives. So I have a pattern here of going up by 5 each time as I reduce the number of -5s that I'm add by, which seems pretty obvious, right? So think about what would -1 times -5, that would follow this pattern, right? And we'd end up with 5 more than 0 or 5. Well, they're not showing us this yet. They want us to think about when I have a positive and a negative, I end up with a negative result. And that's a rule that they give us here. To multiply a positive and negative, and multiply their absolute values, the distance from 0, which is, like in this case, 8 times -5. The absolute value of 8 is 8. The absolute value of -5 is 5. So you end up with 40. And then if I have a positive and a negative, I'm going to have a negative result. I like to kind of go the other way. Just reverse that, is determine your sign first. And we'll talk about some shortcuts, or basically some patterns you'll see as far as determining the sign of your answer, whether it's going to be negative or positive. So I'd look at this and just first I'd say, is this going to be a negative or a positive product answer to my multiplication? Well, according to this rule, it's negative, right? And then even with a calculator, if I need to pull out a calculator, I would, what happens on calculators is you make mistakes putting in keystrokes. You put in an extra keystroke, or you forget a keystroke. And negatives could be easy to make a mistake on. So I would just take 8 times 5, and I know it's going to be a negative result. My calculator would display 40, and then I put a negative in front of it because of this rule. Same thing here. I know I'm going to have a negative result. It's going to be a fraction, which is I try to pre-simplify, but there's no common factors between the numerators and denominators, so it's just 1 times 5 over 3 times 7. So I get 5 over 21, and I know it's negative. Multiplication property of 0, we're going to use that a lot when we get further into algebra courses where we're working with quadratics and trying to find solutions, so we're going to end up with things that multiply equal to 0. But that's quite a ways down the road. Basically, this is one of these properties too. It's very obvious, those kinds of things, and it's easy to just kind of blow by some of these definitions. But remember that you don't prove things in algebra just by saying, hey, 0 times 1 is 0 and 0 times 2 is 0. It looks like all numbers it works. I could say, well, what about the next one? We have an infinity of numbers. What about a negative 5? What about negative 1/5? And so on, times 0. Well, they give us a property that basically says no matter what you multiply 0 by, right, or times it, you're going to get a 0 product answer to that multiplication. So they show us some things here. I could look at this right away. It's all multiplication. I got multiplication by 0. I wouldn't even do this. I would just say, hey, I know the answer is 0. Okay? And jump right to that. Well, here they're that pattern again where they're showing the positive times a negative, and they're showing the addition equivalent. And then they say, well, if it's going to follow this pattern here, it really should increase by 5 as I go down by 1, right? And that's what it does. So if negative 1 times negative 5 is a positive 5, or the negative of negative 5 is 5. Or another way to say this, the additive inverse of negative 5 is 5. And when I talked about additive inverses in addition, that's what I was saying. There's really 3 ways to say the same thing. The opposite of is the same as multiplying by negative 1. Or the additive inverse is the same as multiplying by negative 1. And that's going to be pretty valuable when we get into more complex expressions and equations. But basically they're showing us by pattern, and they don't show us the whole proof, but they're saying if you have 2 negatives multiplied, you're going to end up with a positive result or positive product. And that's this law right here, the product of 2 negative numbers. So like same idea, I would determine sign first. I have 2 negatives multiplied. I know I have a positive result. And I would put 6 times 8 in my calculator just to make sure that I get the right answer, 48. I know this one's positive, but I put 1.2 times 3. I know I get a positive 3.6, and so on. Now, when we pair things, so they're telling us that if we have a pair of negatives, I get a positive result. Well, one of the nice things about multiplication is I can use the commutative property, which changes the order. I can change the order any way I want as long as it's all multiplication. And I can also change grouping. And that's what they're showing us here. If I multiply the first 2 numbers here, I have negative 3 times negative 2 times negative 5. Well, order of operations would be you'd multiply the first 2, right? And I would get a positive 6. So then I end up with the next multiplication is going to be a positive times a negative. So you do it, one multiplication at a time, and I end up with a negative. Now in this case I have 4 negatives. I could group these, couldn't I? Could I just group these? Let's just think about sign, not necessarily the answer to this thing. But I can group these like negative 4 times negative 6, and then I could group negative 1 times negative 2. Not that that's the only way you could do that, but that's using the associative property. And I'd end up with a positive times a positive. I think I know what that is, right? And that's what they do here. They say, well, what if we group these negative right here? They put them in red, and here they put that. I wish they would have used properties we already know. instead of making colors and all that kind of stuff, they could have just put parentheses around these and say that they use the associative property, because I can group it any way I want. So what they're doing is saying, hey, I got a pair makes a positive and a pair of negatives make a positive, so I end up with positive times positive, and I get a positive 48. And that's what they're trying to illustrate here. A product of an even number of negative numbers is positive. In other words, I count the negatives. I got 1, 2, 3, 4. I end up with something I can pair up to make positives, right? And they all pair up. Here, this one, I only have 2 that pair up, but I still have 1 negative left because it's an odd number. So I end up with a negative result, and that's what they're putting here. I wish they would really, they did, highlight this by making it bolder print, but it's almost really a property in a sense, and it's going to save a lot of times, but it's not really a property. It's really a strategy, a problem-solving strategy, to maybe take less steps, less keystrokes, enter into a calculator, a lot of different things that can happen in those things. Less steps means less chances for error. That's a good strategy for problem solving. Well, then they give us this property of -1. It says for any real number a, -1 times a is a negative a. Or to say it in English, -1 times a is the opposite of a. I can say that in another way in English. -1 times a is the additive inverse of a. Okay? Because we talked about that before. Additive inverses and opposites are the same. So really, this is that third part that I was talking about in addition, subtraction. It's pretty good to understand that this way. In fact, this, thinking of it as a multiplication, is going to be more useful in probably 90% of your problem solving in an algebra class. This is a very important deal. I hear a lot of students say, well, I just have trouble with signs. I get the wrong signs on my answer. It's not that big a deal. It is a huge deal. I mean, at the very least, you're only going to get half credit on a lot of problems. Sometimes you will get no credit at all for having the wrong sign on your answer. So it's like saying, I hate to go back to grades for some reason to learn something, but it'd be like saying the best you're ever going to do if there's any signs involved is get a 50%. I mean, not a good plan. Well, now they're going to go through division. Now, we've already talked about division as really multiplication by multiplying by its reciprocal or multiplicative inverse. And then we apply all the rules to multiplication that we have. Well, we just went through some more rules on multiplication, so basically the same rules apply to division when it comes to negatives. So they talk about rules for multiplication and division. To multiply or divide two non-zero real numbers, use the absolute values, multiply or divide as indicated. If the signs are the same, the answer is positive. If the signs are different, they're negative. Okay? I kind of reverse that order. I determine the sign first, and then absolute values is distance from 0. So like this one here, I know the result of this division, or the quotient, the answer to this division is called a quotient, is going to be negative. In this case, -2. This quotient, fractions are division too. And I could say this in a way, I could say simplify this fraction too, would be one way. Or do the division, which happens to make this, this ends up to be a whole number. Or integer, whole numbers are always positive. But it is a whole number, but it really is in the integer set, probably be a better way to describe it. But I know it's going to be positive because I have a negative and a negative. This one's going to be negative. This one's going to be something we're going to have to talk about here. So if I follow these rules, the absolute value of -32 is 32. The absolute value of -4 is 4. I take 32 divided by 4, I get 8. I have a positive result because there's two negatives. Let's look at this D here though. If you think about multiplication is multiple adding, right? In fact, that's how they described and set up how we're going to deal with these rules as far as signs, was to show multiplication as multiple addition. Well, what is division? Division is really multiple subtractions. So when I'm saying something like 32 divided by 4, that means how many times can I subtract 4 from 32 to get to 0? And that really goes back to grade school when we were thinking about, when we had the little blocks or um, pieces of things that we're counting and stuff, and they say, well, let's split this into groups of 4, right? So we have 32 of these little pennies or something, and we said, well, let's split them into groups of 4 to see how many groups of 4. What do you actually do as a kid when you're doing that is you have this big group of pennies and you grab 4 and you move them away from the big group, right? You subtract them from the group, and then you subtract 4 more, and you subtract 4 more, and subtract 4 more. In this case, you end up doing that 8 times. So that's what we're doing, is counting the subtractions that can occur. And if it didn't end up to be, if there was still some pennies left, like it was 33 divided by 4, we'd go 4, 4, 4. I get 8 4s I could group up, and then I have 1 left over, or 1 remainder. That's where that word remainder comes from. Well, hope that cues up some memories of grade school, and tying back to what we're really doing and what the definition of division is. It's multiple subtractions, rather than, they used to say, well, it's hard to memorize division, so we'll just pretend, we did all this work to memorize multiplication tables. Let's just keep tying division back to multiplication. And that's what they say. Division's the opposite of multiplication. So we kind of tend to stay on that side of the operation deal. But it's important to understand what division is, because look at D now here. Example D. Negative 17 divided by 0. Now the definition of division is multiple subtractions. So what I'm saying is I have a negative 17. I'm going to subtract 0 from that, and see how many times I can subtract 0 from it, and it'd be easier to visualize with positive numbers. Let's say it's 17, and I'm going to subtract 0 from it, and I'm still, nothing comes out of the pile, and then I subtract 0 again, I subtract 0. I could keep doing that forever, and I still get no closer to 0. Nothing's happening. I can't even say that it's infinity or anything else. It just doesn't make any sense. It's just not performing anything. So what they do is they say division by 0 is undefined. It makes no sense as far as what we're trying to do with that operation. So we look at this number. When we multiply 0 by, it gives negative 17. It doesn't work with this opposite thing. You need to think about what's going on here with division. So anytime you have a divisor or a denominator of a fraction, this is really a division. If I wanted to write this like in this form, it would be negative 17 divided by 0. Okay? So this is the divisor. This is a divisor in this case. If the divisor or denominator of the fraction is equal to 0, it is undefined. Okay? This is a very important little rule here, and it's going to be one of the things. If you're still thinking you can get through algebra by memorizing some techniques to get through some example problems, I hope I can break this, because it's going to be very frustrating, because I can present a problem, especially when it comes to these negatives. There are 3 different ways of expressing a negative fraction that are exactly the same thing. I can have negative a over b, or a over negative b, or the negative of the fraction a over b. They all mean exactly the same things because of these rules that happens with negatives. And then if I have a negative a over negative b, that's the same as a over b. In this case, we'd probably say simplify this fraction, and we would want the answer as a positive over a positive, because simplest form means that the only common factor between the numerator and denominator is 1. In this case, there is a common factor of negative 1, and we're going to talk about using that to our advantage in a lot of different ways too. So they want us to rewrite each one of these fractions in the equivalent form. So here is the form that they give us here. 5, a positive number over negative 2, a negative number. Here's positive over negative. Well, I want to write it as negative 5 over positive 2 this way, or the negative of 5 over 2, okay, this way. And that's what they show us right here. So there's 3 ways to represent any negative fraction. And then in this case, they give us the negative of 3/10. I could write that as negative 3 over 10 or 3 over negative 10. Now, I'm not going to say any of these are better than the others, though usually this is the form that they want answers to be in, or the end result of evaluation of an expression or solving an equation, those kinds of things. But there are going to be times when we're going to want to create this version of it to make things simpler, and it brings in strategies again on how we're going to deal with solving equations or whatever they're asking us. So example 7 here says perform the indicated operation. And when I look at this, first of all, I have a multiplication of 2 fractions. I should know what the result is, because this is really just a negative 4/5, right? Well, isn't this just a negative 7/3? Couldn't I rewrite that as a negative of 7/3, right? And that's what they do first. And they want you to see that basically this is a negative number times a negative number. I'm going to have a positive result, okay? Then I look before I multiply if I can pre-simplify. There's nothing to pre-simplify. So really it's just 4 times 7 over 5 times 3, and you get 28/15. Now this one, too, again, is here's a negative number, right? Is this the same as just a negative 9/7? Yes. But they do one more thing here, too, is we're adding here. Be careful that, it's easy. We're working with multiplication. Here's a lot of errors around this. Hey, you get used to doing an example problem, or you're doing exercises after a section. They were talking about multiplication, so we end up doing a lot of multiplication. This is an addition here. What do we need to do addition? I need to have the denominators be the same. And if I remember how I can rewrite negative fractions, or fractions with negative numbers in there, I don't have to do a lot of work to make sure that these 2 denominators are the same. So that's what they do here. They don't say this is, and they take advantage. This is problem solving. I could say this is negative 2/7 and then say this is negative of 9/7. But they bring up the numerators to be negative, because isn't that how we do addition? Once I have the denominators exactly the same, what do? I add the numerators. So I might as well have the correct number up there. Use positive for your denominator, which you could use negative, but that just complicates, puts another step in complication to it. But then I'm going to do the addition, negative 2 plus negative 9, which is negative 11/7. There's that form, but they also say you could write this as a negative 11/7, negative of 11/7. Okay. Now, here's another place, another examples go to a lot of places where we see errors, is find the reciprocal of. Now, reciprocal, the definition of a reciprocal is when I take a number times its reciprocal, I get the identity of multiplication, 1. So if I have 2 and I want to multiply by something to get 1, I have to multiply by 1/2, 1/2, because 2 times 1/2 is 1. If I have 1/3, or let's say 2/3, 2/3, well, the reciprocal of that is 3/2, and people bring up this flippy thing and all that kind of stuff. But 3/2 times 2/3 is 1. That's why they're reciprocals of each other. Let's look at B. Negative 3 over positive 4. What's the reciprocal of that? Well, first of all, I have a negative fraction. I need, when I get done with the multiplication times a reciprocal, it has to equal a positive 1. That's the definition of a reciprocal or multiplicative inverse. So I know just based on this, that this needs to be a negative number that I'm going to multiply to get my positive 1. So the reciprocal is going to be negative. The reciprocal of negative 27 is going to be negative. The reciprocal of negative 1/5 is going to be negative. Okay? And then they show this, and if you usually people get stumped by reciprocals, but as soon as I rewrite negative 27 as a fraction, which is the same as negative 27 over a positive 1, then everybody sees the reciprocal. Well, I could put 1 over negative 27, right? And if I multiply those two things, I get 1 definition of reciprocal. Here's 4 over negative 3, or negative 4/3, check by multiplying, get 1. Reciprocal of negative 1/5 is a negative 5, or negative 5 over 1, and I get 1. Well, the reciprocal of 0 does not exist, because there's nothing I can multiply times 0 and get 1. That's a definition of reciprocal again. So there's no reciprocal for 0. Division. Okay, and that's why it's important to review this reciprocal thing, because when we're dividing by negative numbers, or the divisor, the part that's being divided by, or if it's in a fraction form, the denominator, is I need the reciprocal in this case of negative 5/4. So that's a negative 4/5. You don't drop the signs, you get in here. What's the confusion? It's based on, again, going back to addition, where additive inverses are opposite of, or the negative 1 of, right? All three of those things are saying exactly the same thing. And when I add those two things together, I get the identity of addition, which is 0. Not with multiplication. I need to get the identity of multiplication, which is 1 when I multiply. So that sign thing, thinking, oh, that's easy, just change the sign deal, and everything else. Tie back in. When you're working on your assignments, you should always be trying to tie back into definitions of the words. You're going to be tested on the words. Great way to study is actually, when you do your assignments, ask yourself why. Why? Why would I be able to do this? Well, in this case, changing from division to multiplication is because we're taking the divisor and multiplying by its reciprocal. Okay? Then you just follow the rules for multiplication. So in this case here with example B, I got a negative divided by a positive. I should know what my result is going to be, positive or negative. I would do that right away. Then I can forget about making a mistake that happens all the time when we're changing reciprocals. Take the sign of your division, pretend that they're all positive, or take their absolute values, and make sure you still get your reciprocal. Multiply, make sure you got the right sign on your result. Okay, so that's really what I'm talking again, it's about problem solving. I'm applying some of these rules that we did, but I want to apply it in a way that makes it more effective on getting my solutions and my right answers. Here they show a long division way, basically, of doing this with decimals and so on. I would still probably change that to a multiplication maybe, but I definitely would not put the signs in there. I'd say, hey, I got a positive divided by a negative. I'm going to have a negative result, and then do whatever I need to do to find out what the number is. Again, they go into this division by 0 thing comes up, and they're actually going to define that. And they want to point out that if you have a numerator of 0 and a number in the denominator, the result is 0. It's like saying, I want to, if I had 0 things and I want to pull them out into groups of 2, well, I can't pull any out. I'm done. I can do it 0 times. I can actually do it amount of times, and I'm already at 0. That's 0. Where 5 divided by 0, I have 5 things. I'm pulling out 0 of them at a time, trying to figure out how many zeros I can pull away from there to get to 0, which makes no sense, which is why division by 0 is undefined. And that's this thing right here. For any real number A, And it's good to go through this stuff because we're going to do a lot of this. This little statement, this little one line, defines everything that I said in a lot of words up here trying to describe what's going on with division of 0. But it says for any numbers a over 0, a divided by 0 is another way to say that, or the quotient of a and 0 is undefined. That's not defined. And so for a is not equal to 0, we got to define that. We got to say, hey, a cannot be equal to 0 in this case, where I have 0 divided by some number other than 0. Well, it won't work for 0 because we already covered that here. That would be undefined. They want to get this idea what happens with zeros when it's not undefined. Okay? So 0 divided by any number is 0. So they kind of come back to this reciprocal, and this is, like I said, this is a very common error. I think I've covered this whole thing, is that we tend to associate addition and multiplication, but these rules don't actually, shortcuts or just pretending. Whenever you hear anybody, if you're talking to a tutor or even with yourself, you're saying, oh, I just need to do this. I don't have to talk about or understand what reciprocals are, multiplicative inverses, additive inverses, or opposites of, or what's all this big deal about multiplying by -1, those kinds of things. Should be a caution for you, is tie your homework into definitions so you remember the actual definitions, the algebraic definitions, the language of algebra, and then apply that in the many different ways that you can apply it, and you're going to be a lot more successful. Then they connect the concepts here right before the end of this section, and really they're pointing out, hey, let's mix these things together to make sure you can do both. And because, like I said, we're used to doing, here's multiplication thing, and then you do a bunch of multiplication. Here's a division thing, you do a bunch, But reality is you're going to get mixed. You're going to have addition and subtraction and multiplication, division, all those kinds of things going on at the same time. And I think that finishes up this section. Yep. So then they go on to exercises.